Alright, so picking up, light varies with depth, okay, and that should just be intuitive. So when light strikes the surface of water, a certain amount is reflected back into the atmosphere. The lower the angle, the larger the amount of light reflected, okay? Two additional factors also affect how much light enters water. One is suspended particles. So the more particles are suspended, the less light that's going to get through, okay? And two, water itself absorbs light. So water absorbs light. And the water absorbs light in the visible frequency or the visible range for red first and infrared first. So what ends up happening is you don't see the red light anymore once you reach a certain depth. Then yellow, then green, then violet, leaving only blue wavelengths to penetrate deeper water. So a fraction of blue light is lost with increasing depth. So as you go further and further, the fraction of blue light gets less and less. So the properties of water's absorption of light frequency, especially in the visible range, are important in determining what kind of how much light is penetrating the water. And temperature also varies with in deep water. Okay, so the exponential decline of solar radiation with water depth also gives rise to a corresponding decline in water temperature. Okay, and that makes sense because we know that the sun heats up the water. Okay, so if there's less light and less energy reaching the bottom, let's say, then you're not going to have as much heat being produced. And the region of the vertical depth, okay, where most rapid decline in temperature occurs is called the thermocline. Okay, the depth of the thermocline will depend on the input of solar radiation and temperature of surface water. So as air temperatures start to cool and sunlight decreases, the surface water begins to cool. And as it does, the water becomes denser and sinks. So this is kind of how water circulates, or how we have that circulation. Displacing warmer water below the surface where it cools in turn. Okay, the process of vertical circulation is called the fall turnover. It is an important component of nutrient dynamics in open water ecosystems. And the temperature of flowing bodies of water is variable and tends to follow the air temperatures, although slightly behind. So the water temperature rarely dips below freezing in the winter, and other factors such as shade that block light and the amount of light that hits the stream can also affect the type of organisms that can survive there. And that is, are they cool water organisms or warm water organisms? It will depend on the amount of light that's getting through there and the temperature conditions. So water functions as a solvent as well. So if we start with a spoonful of sugar into water, it causes it to dissolve. So we put a spoonful of sugar in water, and it dissolves, okay, forming a uniform mixture. So a liquid that is a uniform mixture consisting of two or more substances is a solution. Alright, and the dissolving agent of the solution is the solvent. So the dissolving agent is the solvent, and the substance that's dissolved is known as the solute. And a solution in which water is a solvent is called an aqueous solution. So these are kind of just basic definitions that we've all heard before. Water is an excellent solvent with the ability to dissolve more substances than any other liquid. So water is a great solvent. It really works to dissolve a lot of other substances. And this ability makes it biologically crucial. Okay, it provides the necessary solvent to dissolve chemicals and waste products. And it helps regulate temperature and preserves chemical equilibrium. All important factors. So water has a permanent dipole, so a positive charge on the hydrogen atoms and a negative charge on the oxygen, and it strongly attracts other molecules carrying a charge. So compounds that consist of electrically charged atoms or groups of atoms are called ions. Alright? And when something like sodium chloride is placed in water, it readily dissociates into Na+, or sodium ion, and Cl-, or the chloride ion. And thus it is dissolved. Okay, the concentration of solutes does not continue to increase indefinitely, though. We all know this. If you add enough solute to a solution, eventually it will precipitate out. Okay? So it reaches what's known as a maximum solubility. And the excess amounts will end up, again, precipitating out of the solution. So the determination of the most abundant element, chlorine, is used as an index of salinity. So salinity is expressed in practical salinity units, or PSU, and that's represented by a percentage measured in grams of chlorine per kilogram of water. So that's just a measurement for salinity. So oxygen diffuses from the atmosphere to the surface waters. Okay? Diffusion is a general tendency of molecules to move from a region of higher concentration to one of lower concentration. Okay? It is the process of diffusion that results in a net transfer of two metabolically important gases. And those important gases are oxygen and carbon dioxide from the atmosphere. So in the atmosphere, there's a higher concentration of oxygen and carbon dioxide. And in the surface water, there's a lower concentration. So it's natural for the tendency of for diffusion to have this tendency to go from the higher concentration atmosphere to the lower concentration surface water. And the rate of diffusion is controlled by the solubility of oxygen in water and the steepness of the diffusion gradient. Okay, and that's the difference in the concentration between the air and the surface water. So that's what the diffusion gradient is. And the solubility is a function of temperature, pressure, and salinity. So oxygen is lost from water as temperature rises due to decreasing solubility. In the lake, stratification is a problem. The late fall turnover results in both a uniform temperature and a uniform distribution of oxygen throughout the lake basin. So in summer, a pronounced stratification of both oxygen and temperature exists. So oxygen levels decline sharply and are non-existent at the bottom because of the uptake by decomposer organisms. In winter, oxygen is also stratified, but it is present in low concentrations in deep water. Okay? So the oxygen content of water in the ocean declines to a depth known as the oxygen minimum zone, and the oxygen increases below this zone is thought to be the result of influx of cold, oxygen-rich waters that originally sank in the polar waters. Okay? Now another concept here to move on to is acidity, and acidity has an effect on aquatic environments. The solubility of carbon dioxide is somewhat different from oxygen. Okay, it reacts chemically with water upon diffusion into the surface. Carbon dioxide reacts with water to produce carbonic acid. This is much like the blood buffering system, surprisingly. CO2 plus H2O goes over to H2CO3. Okay, so that's carbonic acid further dissociates then into hydrogen ions and into a hydrogen ion and a bicarbonate ion. So H2CO3 goes to HCO3 plus H+. And then the bicarbonate may further dissociate into another hydrogen ion and carbonate ion. So it could further dissociate to H+ and CO3-. So the carbon dioxide carbonic acid bicarbonate system is a complex chemical system that tends to stay in equilibrium. Okay? And the above chemical equations result in the production and absorption of free hydrogen ions. The abundance of H+ ions in solution is a measure of acidity. Remember, it's the negative log of H+. Okay, and the greater the number of H+ ions, the more acidic the solution will be. Alkaline solutions are those that have larger numbers of hydroxyl ions. Okay, and the measure of acidity and alkalinity is known as pH. And just for references, neutral pH is a pH of 7. So, the carbon dioxide carbonic acid system functions as a buffer. Okay, it's a buffer system allowing water to resist changes in pH. So that's really important because you don't want rapid fluctuations in pH. That could be really detrimental to the organisms living in the aquatic environment. So we have this carbon dioxide carbonic acid bicarbonate system which resists changes in pH. So at a pH 7, most of the CO2 is present in the form of HCO3-. So at high pH, most CO2 is present as CO3 2-. And at low pH, CO2 occurs freely. So the addition or removal of CO2 can also alter the pH. So water movements shape freshwater and marine environments. So the movement of water currents and streams and waves in the open body of water, okay, determines the nature of the aquatic environments. And the movement of deep waters of the oceans is quite different from surface currents. Because deep waters are isolated from wind, their motion cannot be dependent on it. So the motion of the deep water currents is not the same because it's not dependent on wind. Movement of deep waters does, however, result in changes occurring at the surface. So seawater increases its density as a result of decreasing temperatures and increasing salinity. When seawater increases its density, it sinks. So as warm, highly saline surface currents move north from the tropics, they cool. And as these waters cool, they increase in density and sink. Because these waters originated on the surface, they contain high concentrations of oxygen. And as these waters sink, they begin to return deep to the tropics, forming the deep water currents. When these deep water currents meet in the equatorial waters of the ocean, they form a region or an upwelling where deep waters move up to the surface, closing the pattern of ocean circulation. And tides in marine coastal environments. So tides influence the life that exists on the ocean shores. And tides come about from the gravitational pulls of the sun and the moon. And each causes two bulges in the waters of the ocean. And the last part here is estuaries. And water from all the streams and rivers eventually drains into the sea. Okay, and the place where the fresh water joins and mixes with the salt water is called an estuary. Temperatures in these places fluctuate considerably, both daily and seasonally, and the interaction of inflowing fresh water and tidal salt water influences the salinity of the environment. So salinity varies vertically and horizontally, often within the tidal cycle.